Hello and welcome to this video on the properties of three-dimensional shapes. This video is part of the Functional Skills Maths course at levels 1 and 2. The learning outcome for this lesson is to identify, recognize and describe the properties of common three-dimensional shapes. Our linked learning links to the properties of two-dimensional shapes, where many of the properties of the two-dimensional shapes carry forward to three-dimensional shapes. For example, a square where all of the sides have the same length, if you make the third dimension the same length, so this is the same length as all the other sides, then you end up with a cube. For a triangle, if you create a third dimension, it becomes a triangular prism. And for a circle as a two-dimensional shape, if you create a third dimension, it becomes a cylinder. So we're just going to look at extending two-dimensional shapes into the third dimension. Here are a few of the three-dimensional shapes you need to be aware of. Can you name them before I reveal them? So the shapes we're going to look at are the cylinder, cube, cuboid, the cone, pyramid, sphere, and triangular prism. In order to describe these three-dimensional shapes, we need to look at their properties and the correct terminology for the shapes. So for any three-dimensional shape, we need to look at the corners where the edges meet. So here we have an edge, and an edge, and they meet in a corner, sometimes known as a vertex. The faces are enclosed by the edges. So here, for a cube, it would have 6 faces, much like a dice. The base is sometimes known as the baseline here, like we had with the two-dimensional shape. Sometimes the base refers to the two-dimensional shape that is at the bottom of our three-dimensional shape. And then finally we'll look at angles within the shape, and here our cuboid we know has lots and lots of right angles associated with it. So here are the three-dimensional shapes we're interested in. See if you can remember what they're called, how many faces, edges and vertices each one has before I reveal them. And here you go. Did you get them all correct? So, as well as the properties, let's have a look at the angles inside our shapes. So, the properties of a cube mean that all of its edges are the same length. Now, what this means is it creates on our square lots and lots of right angles throughout the shape, much like our cuboid. Now, our cuboid is the same as a rectangle with something behind it. So, the angles inside the cuboid are almost entirely made up of 90-degree angles where the edges meet. The angles inside our triangular prism will depend on the type of triangle that is facing you in the two dimensions. So the dimensions of that triangle could dictate what the angles are. And there are two main types that come out of our triangular prism. You have an isosceles triangle where this angle is the same as this, which means this length is the same as this. Now you'll need to be given this angle to work out the other two angles. However, if the edges on your triangle of the triangular prism are all the same length, it means each of these angles are 60 degrees because they're all equal. All of the sides are the same length, all of the angles are the same, so 180 degrees divided by 3 gives us 60 degrees for each angle. It's a similar issue with triangular-based pyramids and square-based pyramids. Now, the angles inside triangular-based prisms and square-based prisms depend on the actual triangles that are being created here. So these angles are dictated by the length of these sides. And again, they can be isosceles or equilateral. And if they're equilateral, they'd be 60. And the angles created with anything else to do with the pyramid, which we'll look at in a moment. So the angles in our three-dimensional shapes, when it comes to triangles, could vary greatly depending on what sorts of triangles they are. And all you need to do then is refer back to the two-dimensional lesson on the types of triangles and the missing angles in those triangles. Now you can create other angles from the vertices to the center of the base of your three-dimensional shape. Now the angles that you create when you do that are totally dependent on the types of triangles that you are creating. So here, if this length here was the same as that height there, then this would be an isosceles triangle, where we know this is 90, therefore this and this are the same angle. So we know the angles inside a triangle add up to 180. We know this angle here is 90. So it leaves us with 90 degrees we have to split evenly between the other two corners or angles. So in this case, this angle would be 45 degrees, providing this and this are the same length. And that completes our learning outcome for identifying, recognizing and describing the properties of common three-dimensional shapes. There wasn't much in the way of slides with respect to the content, and not many exam type questions are out there at the moment on these topics. But there are quite a few buzzwords where you need to be able to recognize the shapes of cubes, cuboids, cylinders, cones, spheres, triangular prisms, and square and triangular base pyramids. So try and remember the properties for those. The terminology you use to describe those properties are the corner, the number of edges, the number of faces, the number of angles, and the types of angles that you get, especially with the different types of triangles, and the base. And that completes this video on properties of three-dimensional shapes. If you'd like more practice with this topic or more information, please don't hesitate to contact your teacher. I hope you've enjoyed this video.